Here's a really fancy graph. Don't really read much to it. I was reading it, and I think the RX Marbles website has better examples. But pretty much what's going on here is at the top we have this line going from left to right. And that's just going to represent a timeline of the observable. So time flows from left to right. And all these objects, these colorful objects here on this chart, they are just events that start off before they go into the observable. And then this operator here that says flip, that's the operation that's going to happen on this observable. And on the bottom, that's the result of the operation when you subscribe to it.
And the reason why I put that in there, it is a bit of a more advanced graph, is because that's what's on the reactive extension site. And so sometimes in order to gain greater insight to the operators, you will end up there, and this is kind of the graphics that they use. So RX Marbles is a little simpler to understand, but I think Andre Staltz has only gotten to maybe 20 operators of the 150 or whatever there is. So some of the stuff you're going to learn about RxJS is just going to be from Reactive Extension site and maybe in some other language even.
So this also is not the point where you're supposed to get it. Don't worry about it. We're going to get there. So here's some of the most common RxJS operators, especially the ones that we're going to be using: map, filter, scan, debounce, distinct until change, combine latest, and flat map. A lot of these, again, sound familiar: map, filter, debounce. We can kind of infer what those are. Flat map, probably. But distinct until change and combine latest, we'll go over that. But I promise you, they're all pretty simple, but yet very powerful. You'll see in a little bit. Any questions so far? You just want to see the stuff? Okay, so here's a marbles diagram of how map works. So at the top, we have these events coming in. Let's say it's just an array of numbers 1, 2, and 3. They're coming in. We make it observable. We subscribe to it. But before we subscribe, we call the map operator. And it does exactly what map would do on an array prototype. It takes in the value, and it's just going to transform it and return a new value. So here we're saying take in x, which could be either 1, 2, or 3, depending on what event's coming in, and multiply by 10. So when we subscribe and we get that value, that's what we get. And for each event in the stream, there's going to be a new event that's emitted. So there's 3 events coming in, so there's going to be 3 events emitted in the same time that they came in. So it's just mapping over them. Nothing new here. Same thing if you did it over an array. And here's what that might look like. Again, have some numbers here. We're going to create an observable from a range of 1 to 3, and we're just going to map over them. That's it. It's pretty simple. Don't worry, we'll go into more examples, some live coding. Filter, same thing, works exactly the way it does on an array prototype, except for apply it to an observable. So the thing with filter is if the event that's coming in doesn't pass the predicate, it's not going to be emitted. So it's just discarded, it's disposed. So that's why only 3 of these events pass, so that's why only 3 of them got emitted. The rest of them just are disposed. So you won't be notified of if something didn't pass, it just doesn't come. Just like if you filtered an array, it won't be added to the result. Any questions here? Nope, okay. So here's an example of how you might do that as well. At the top, that's how you would filter an array, right? Just call filter on it, boom. On an observable, it's pretty much the same thing. We have a range of the numbers 0 through 5, and we're gonna call filter over it to see if it's divisible by 2. Works exactly the same way. And then we subscribe to it. That subscription is actually the syntax is kind of weird if you're not familiar with ES 2015, but those are just 3 callbacks right next to each other. The first callback is the on next, so what happens when a new event is emitted. The second argument is the on error, so what happens when an error is emitted. And the last one is finally everything's done, there's nothing else coming in, I'm completed. So if you want to relate that to promise, that's like .then, .catch, and .finally. Cool, so scan is pretty much just like reduce. It's exactly like reduce with one thing. Whereas reduce only returns the final reduction, the final result. Scan will emit every successful step along the way, every reduction. So reduce would only, for instance, this if we were to use reduce here, we'd only see 15. That's it. That's the last one. Whereas scan is going to do every single one along the way. It's going to emit every single one. It does the same thing as reduce. It just emits every successful reduction along the way. Does that make sense? So we can see every single step, not just the final result. Very helpful. So again, this is some code of how you would do it in an observable. We have a range of 1 to 3, and we're just going to scan over it. And just like reduce, we have an accumulator, and then we have our actual item. And as you can see in the comments below, we get all 3 events emitted instead of just 6, which what reduce would yield. So let's keep it moving. So debounce, I think we all know what debounce is. So when you deal with observables, you sometimes, like you can imagine, because it's a push thing, that these events might be coming in to a point where your subscribers they just can't handle it, right? It's just too much. So you need a little bit of back pressure, is what they call it in observables. So there's 2 types of back pressure. There's lossy back pressure and lossless back pressure. So what does that mean? Lossy means we're going to lose some events. Debounce is a lossy back pressure method, because as you can see, we have all these things coming in, but because we debounced it, we only got 3 of them. So we lost a lot of them. There are other techniques for lossless back pressure, like using a buffer, to where we can kind of buffer up the events and then only get the ones at a certain time or a certain limit in the buffer, so we don't lose anything along the way. So those are 2 types of back pressure. Debounce is just a lossy back pressure method. And it does exactly what you would do in jQuery. You want to debounce a click handler or something like that, it's exactly the same thing. I want to debounce the things over time, only emit something in between this time period. That's it. Yes?
Is that actually back pressure, or it's just dropping? Because back pressure would say stop the observable, but it's not stopping the observable.
No, it doesn't stop the observable. It's just saying, so like, you can imagine like this, you have a pipe, so there's water coming in, right? So this debounce is just like putting something in between that pipe for a little bit and then open it back up. So it does create back pressure, but it doesn't affect the source, right? So I think that's what you were thinking.
Yeah,
like,
because back pressure seems to be
going
pushing
back
onto the observable
Yeah, no,
itself.
it's not affecting the source.
Okay.
No, yeah, definitely. That would be weird if it did that. I don't think anybody would use it. But yeah, that makes sense. Good question. So here's an example of that, of the debounce. Debounce can take in a callback like this, which in this case we're using an operator called observable.timer, or it can just take in any number of milliseconds as its argument to debounce. And we'll go over this one too in a live code example and see where this really works.